So we ended the last video after a talk about pressure and kinetic molecular theory. It was very theoretical, talking about things that we can't really see. I wish I could show you pictures. Want to discuss a practice problem with you. So we're going to convert 33 millimeters of mercury to kilopascals, to kPa, and we're going to do that using this equation that's up at the top. Just so you know, millimeters of mercury is not something that we use a lot anymore outside of science. It's the predominant unit used in science, but outside of science we often use inches of mercury or square inches of mercury, pounds of mercury, square pounds. Those are all different ways that we relate to pressure. You can Google it if you're really feeling like converting, but basically all of this is the air pressure at sea level on a perfectly sunny, cloudless day. So when there is, clouds, one of the ways that they know the clouds are coming is because the air pressure, the atmospheric pressure rises. Now I've kind of gotten into a whole conversation about pressure and haven't talked about a problem yet. So let's get back to that. To convert 33 millimeters of mercury to kPa, we have to figure out our knowns and our unknowns and see if you can look at this equation and figure out our conversion factor. Take a second and try to set that up, and then we'll work it the rest of the way. I was assuming you were going to pause the video. I guess I didn't tell you that. We'll pretend that I did. So now that you've started back up the video, we're going to move forward and talk about the problem. So you first have your known, which was 33 millimeters of mercury, and your conversion factor, your unknown, which is kilopascals. Your conversion factor just simply relates the known and the unknown. So one side has millimeters of mercury and one side is kilopascals. Make sure that when you go back, pause right now if you're confused about where that came from, rewind and look back at the equation that was on the previous board. You'll notice that there was an equal sign there. It doesn't really matter which two things that you relate, just as long as one is on one side of the equal sign and one is on the other. Now when you set up your conversion factor, your brackets or your dimensional analysis, your known goes in the first one like always, and then your conversion factor goes in the second one. This is only a one-step problem. We put the millimeters of mercury on the bottom so that it can cancel, which will leave us with kPa. So we wind up with 33 times 101.3 divided by the 760. And that's how we get 4.4 times 10 to the 0th kPa. That 4.4 has two significant figures because of the 33 millimeters of mercury. Not because of the 760, because it's a perfect 760. Not 761, not 762, a perfect 760. However, this only had two sig figs. So that changed our sig figs of our final answer. If this problem made sense to you, try this one, and we'll start class with this one next time. Convert 4.12 ATM atmospheres to kPa. 4.12 atmospheres to kPa. And we'll start our class next time with that problem. Thanks so much. Enjoy your weekend.